It's almost like magic, isn't it? You type a few words into a language model and boom, you get a response.
Yeah, feels like that sometimes.
But just like any powerful tool, the real magic comes from knowing exactly how to wield it. And that's what we're diving deep into today, the fascinating and rapidly evolving art and science of prompt engineering.
Mm-hmm.
Forget thinking, this is just for tech wizards. This is for anyone who wants to unlock the true potential of these incredible AI tools.
Absolutely. Think of prompt engineering as the key to having a truly effective conversation with these large language models.
Right.
It's about carefully crafting your instructions, your prompts, so they guide the AI to generate the specific high-quality outputs you need. It's not just about what you ask, but crucially, how you ask it.
And today, we're doing exactly that.
Okay.
A comprehensive deep dive into a detailed class all about prompt engineering. Consider this your express lane to understanding the core principles and practical techniques that can seriously level up your prompting skills.
Yeah, a real shortcut.
Our mission today is clear: to equip you with a solid understanding of various prompting methods, how to fine-tune the language model's settings to your advantage, and give you actionable tips to become a much more effective prompt engineer. Okay, let's unpack this foundational knowledge.
Okay, so let's start with a crucial point. The words you type in your prompt aren't the only thing that dictates the output.
Oh, interesting. What else is there?
Well, the way a language model is configured also plays a significant role in what it produces. Let's begin with output length.
Okay, output length. That sounds straightforward.
It is, pretty much. It's simply about controlling the number of tokens the model generates. Now, you might think that limiting the number of tokens would automatically make the output more concise in style, but it's more about telling the model when to stop generating.
Ah, so it's a cutoff point.
Exactly. Interestingly, this becomes particularly important in more sophisticated techniques like React, where you want to keep the model focused and prevent it from going off on tangents after it's provided the core information.
Right, it's about setting those boundaries. Now let's talk about something a little more intricate: sampling controls.
Mm-hmm.
As we know, language models work by predicting the probability of the next word, or token. Sampling is the mechanism the model uses to decide which of those probable tokens actually becomes the next part of its output, right?
That's it, exactly. And there are a few key settings we can adjust here, starting with temperature.
Temperature. Okay, I've heard this one mentioned a lot. What does it actually do?
Temperature is a really intuitive setting, I think. It essentially manages the randomness in the model's token selection.
Randomness. How so?
Well, a low temperature, say close to 0, makes the model more deterministic. It will consistently pick the most likely next token.
Okay, so low temp for facts, predictable stuff.
Precisely. This is ideal when you need factual, predictable, and consistent responses, almost like asking an expert for a direct answer.
Makes sense.
On the other hand, if you crank up the temperature, the model becomes more adventurous, leading to more diverse, unexpected, and potentially creative results. Think of it like brainstorming with a very imaginative, though perhaps slightly less focused mind.
Huh, okay. So high temp equals more creative, maybe a bit wild.
Yeah, potentially. The Gemini temperature control operates similarly to the softmax function in machine learning, where a low setting strongly favors the most probable options, while a higher setting broadens the range of possibilities it considers.
Gotcha.
Be cautious with extreme temperatures, though. Too low, and the model might get stuck in repetitive phrases. Too high, and the output can become nonsensical.
Right. Don't want gibberish. Okay, so temperature controls the overall level of surprise in the output. Now, what about top K and top P? These sound like they're about narrowing down the model's choices.
Precisely. Top K and top P, which is also known as nucleus sampling, are ways to restrict the model's choices for the next token to only the most probable ones.
How does top K work?
With top K, you're setting a fixed number, K, and telling the model to only consider the top K most likely tokens. A higher K gives the model more options, leading to more varied output, while a lower K makes it more focused and factual.
Okay, so K1 would be...
That's essentially the same as that deterministic greedy decoding we mentioned with low temperatures. If you set K to a very high number, you're practically including almost every token in its vocabulary.
Got it. So K is a hard limit on the number of choices.
Yeah.
How does top P differ?
Top P, or nucleus sampling, takes a slightly different approach. Instead of a fixed number of tokens, it looks at the cumulative probability.
Cumulative probability.
Yeah, you set a probability p, and the model considers the smallest set of tokens whose combined probability exceeds that p. So a p of 0 is again that greedy decoding, focusing on the single most likely next token, while a p of 1 means all tokens are potentially in play.
Ah, okay. So top K is a fixed number, top P is a probability threshold.
Exactly. The key difference between top K and top P lies in the selection criteria. Top K sets a fixed number of candidates, which can be useful when you have a general sense of the vocabulary you expect. Top P, however, adapts to the probability distribution of the next tokens.
Which could be better sometimes.
Potentially,
Right,
yeah.
right.
It might handle situations better where the likely words are either very concentrated or more spread out. Ultimately, the best way to decide whether to use top K or top P, or even both, is really through experimentation to see what yields the best results for your specific task.
Experimentation seems to be a recurring theme here.
It really is with prompt engineering.
Now, how do these three, temperature, top K and top P, interact if you have access to all of them, like in Vertex Studio?
That's a great question. When all three are available, the model first applies both the top K and top P filters to the list of potential next tokens.
So it filters twice.
Yep. Only the tokens that make it through both of these filters are then considered for the final selection. Finally, the temperature setting is applied to this remaining set of tokens to determine the final output.
Okay, break that down a bit.
Think of it like this. Top K narrows down the number of candidates, like saying, only consider these top 30 words.
Right.
Top P looks at the likelihood of those words and says, take words until their combined chance of being next reaches 95%.
Okay.
Temperature then adds a little bit of controlled randomness to the final selection from this filtered group.
Got it. Filtering, then sampling with randomness. What if you only have one filter available?
If only top K or top P is available, then only that single filter is used. Simple as that. And if temperature isn't available, then a token is randomly selected from whenever tokens meet the top K and/or top P criteria.
Okay.
It's also worth remembering that extreme settings for one of these can sometimes override the others. For instance, a temperature of 0 essentially makes top K and top P irrelevant because the model will always pick the single most probable token.
Ah, right. Deterministic wins.
Exactly. Similarly, a top K of 1 leaves no other choices, and a top P of 0 often has the same effect.
That makes the interaction much clearer. So with all these controls, where should someone even begin when setting these parameters? It feels a bit overwhelming.
It can seem like it, but there are good starting points. As a general guideline for relatively coherent results that still have some creativity, you could try a temperature around 0.2, maybe a top P of 0.95, and a top K of 30.
Okay, balanced settings. What about going full creative?
If your goal is highly creative output, you might want to bump those up to a temperature of 0.9, a top P of 0.99, and a top K of 40.
And for more factual, less creative stuff?
For tasks where you need less creativity and more focus, perhaps a temperature of 0.1, top P of 0.9, and top K of 20 would be a good starting point.
Makes sense.
And for tasks where there's likely a single correct answer, like solving a math problem, beginning with a temperature of 0 is usually best.
Good rule of thumb.
Just keep in mind that giving the model too much freedom with higher settings can sometimes lead to outputs that are less relevant to your original prompt. You might get creative nonsense.
Right, got to stay on track. Okay, we've got a good handle on how to configure the language model's output. Now let's move on to what many consider the real heart of the matter, the prompting techniques themselves.
Exactly. Language models have been trained on vast amounts of data and are designed to follow instructions. But the clearer, more strategic, and more nuanced your prompt, the better and more relevant the results you're going to get.
So better input, better output.
Pretty much. Let's start with the most basic approach, general prompting, which is also often referred to as zero-shot prompting.
Zero shot sounds like we're starting with no help at all. What exactly does that entail?
In zero-shot prompting, you essentially give the language model a task description and some initial text to work with, but without providing any examples of the kind of output you're hoping for.
It's just the instruction, basically.
Right. It could be a direct question, the beginning of a story you want it to continue, or a set of instructions you want it to follow. The term zero-shot quite literally means 0 examples.
Okay.
In our class, we looked at an example where the goal was to classify movie reviews as positive, neutral, or negative using the Gemini Pro model.
How'd that go?
We used a low temperature of zero point 0.1 because we were aiming for an accurate classification, not creative interpretations. The top K and top P settings were left at their default, effectively disabling them for this particular case.
Okay, and the prompt?
The prompt is straightforward. Classify movie reviews as positive, neutral, or negative. Review. Her is a disturbing study revealing the direction humanity is headed if AI is allowed to keep evolving, unchecked. I wish there were more movies like this masterpiece. Sentiment.
Interesting review. Kind of mixed signals there. What did the model say?
And the model correctly identified the sentiment as positive, even though the review contained both negative, disturbing study, and positive masterpiece phrasing, demonstrating its ability to understand the overall context.
That's insightful how it weighed those seemingly conflicting opinions. So zero shot is our starting point when we have no examples to offer. What happens when that's not quite enough to get the desired results?
That's when we move to providing demonstrations or examples directly within the prompt itself. This leads us to one-shot and few-shot prompting.
Okay, adding examples.
Exactly. Providing even a single example can be incredibly helpful for the model to grasp what you're asking for, especially when you need to guide it towards a specific output structure, format, or style.
So one example is one shot.
Yep. A one-shot prompt includes just one clear example of the desired input and its corresponding output. Few-shot prompting takes this a step further by providing multiple examples.
More than one.
Right, showing the model a more comprehensive pattern to follow and significantly increasing the likelihood that it will adhere to that pattern for the rest of your task.
How many examples are we usually talking about with few shot? Is there a typical number to aim for?
Well, there's no strict rule, but a good general guideline for few-shot prompting is to include around 3 to 5 high-quality examples.
3 to 5, okay.
However, the ideal number can really depend on how complex the task is, the quality and relevance of your examples, and the inherent capabilities and any input length limitations of the specific language model you're working with.
So it varies.
Definitely. For more intricate tasks with many possible variations, you might find you need to provide more examples. Conversely, for simpler tasks, or if you're running up against the maximum length of the prompt the model can handle, fewer examples might suffice.
Can you give us a practical example of few-shot prompting in action?
Certainly. In the class, we looked at an example of parsing customer pizza orders into a structured JSON format using Gemini Pro.
Structured output. That seems like a good use case.
It really is. Again, we used a low temperature to ensure consistent output and a slightly higher token limit to accommodate the more detailed JSON responses. The prompt began with the clear instruction: parse a customer's pizza order into valid JSON. Then, it provided several examples of pizza orders and their corresponding JSON representations. For instance, an order like, I want a small pizza with cheese, tomato sauce, and pepperoni was shown to correspond to a specific JSON structure detailing the size and toppings.
Showing the format.
Exactly. Another example illustrated a large pizza order with different ingredients and its JSON equivalent. Finally, the user presented a more complex request. Now, I would like a large pizza with the first half cheese and mozzarella, and the other tomato sauce, ham, and pineapple.
Ooh, a tricky one. Half and half.
Yeah. And the model successfully parsed this more nuanced half and half order into the correct JSON format, demonstrating how the prior examples guided its understanding of the desired output structure.
That really highlights how examples can teach the model the desired output format. So what makes for truly effective examples in one-shot and few-shot prompting?
Good question. The key characteristics are relevance, diversity, high quality, and clarity.
Okay, break those down.
Your examples should directly and unambiguously relate to the specific task you want the model to perform. They should also be diverse enough to cover a range of typical scenarios and even some less common edge cases to make the model more robust in handling different inputs.
Edge cases, like unusual requests.
Exactly. It's crucial that your examples are accurate and well-written, as even small errors in your demonstrations can confuse the model and lead to undesirable or incorrect outputs.
Garbage in, garbage out.
Pretty much. If you anticipate the model needing to handle unusual or unexpected inputs, make a point of including such edge cases in your examples to prepare it.
Okay, we've covered general, one-shot, and few-shot prompting. Now, our outline mentions system, contextual, and role prompting. These sound like different ways to provide guidance beyond just the main query and example.
Exactly. These are indeed distinct but often complementary techniques that help steer the language model's text generation by focusing on different aspects of the interaction. Let's start with system prompting.
System prompting, what's that about?
This is all about setting the overall context, background and overarching purpose for the model. It essentially defines the big picture of what you want the model to do throughout your interaction.
Like setting the rules.
Kind of, yeah. Whether it's consistently translating languages, classifying different types of text, or adopting a particular style of writing. Think of a system prompt as providing a fundamental, overarching instruction to the system itself.
Give me an example.
Okay. For example, you could use a system prompt to specify that the model should always return its output in uppercase letters, as we saw in one of our class examples where a movie review sentiment was classified and then presented in all caps.
Simple enough.
More powerfully, you can use system prompts to instruct the model to consistently return its output in a specific structured format, such as JSON.
Back to JSON. Very useful.
Incredibly useful for tasks like data extraction, as it ensures you get organized, predictable, and easily processable data, and it can even help reduce the occurrence of hallucinations by enforcing a clear structure.
Reduces hallucinations.
By giving it less room to just make things up, basically. It has to fit the structure. System prompts are also extremely valuable for setting guardrails, such as for safety and toxicity control, where you can include instructions like, you should always respond in a respectful and helpful manner.
Right, setting behavioral guidelines. So system prompts are like laying down the fundamental rules of engagement. What about role prompting?
Role prompting takes a different but equally effective approach. Here, you're essentially assigning a specific character, persona, or identity to the language model.
Like telling it to be an actor.
Sort of. This helps the model to generate responses that are consistent with the assigned role's assumed knowledge, typical behavior, characteristic tone, and established style of communication.
What kind of roles?
You could prompt a model to act as a seasoned book editor, an enthusiastic elementary school teacher, or even a highly motivational speaker. Once the role is clearly set, all of your subsequent prompts and the model's responses will be framed within that persona.
That's cool.
We looked at an example where the model was asked to act as a knowledgeable local travel guide in Amsterdam and provide 3 museum-focused travel suggestions based on the user's request.
That's dating character.
Yep. What's particularly interesting about role prompting is that you can often further refine the persona by also specifying the particular style that role should adopt, things like being confrontational, highly descriptive, direct, and to the point, very formal, lighthearted, and humorous.
Oh, lots of styles.
Highly influential, casual, and informal, deeply inspirational, or particularly persuasive. We even had a fun example where the travel guide in Manhattan provided sightseeing suggestions, but adopted a distinctly humorous style, resulting in a very different and entertaining output.
Huh. A funny travel guide AI. That sounds like a fantastic way to inject a specific flavor or personality into the AI's responses. Now, how does contextual prompting fit into this picture?
Contextual prompting is all about providing specific details, relevant background information, or current circumstances that are directly related to the particular task you're asking the model to perform at that moment.
So giving it the immediate background info it needs.
Precisely. By giving the model this immediate and relevant context, you help it to better understand the specific nuances of your request and to tailor its response much more precisely.
Makes sense. Less guesswork for the AI.
Exactly. Providing sufficient context ensures more seamless and efficient interactions because the model can more quickly and accurately grasp exactly what you need and generate more targeted and appropriate answers.
Can you give an example?
Sure. For example, if you're prompting the model to suggest article topics for a blog that focuses on retro 80s arcade video games, explicitly stating that context in your prompt.
My blog is about 80s arcades.
Right. That will lead to much more focused and relevant suggestions compared to a more general request for just blog post ideas.
These all seem like incredibly powerful ways to guide the model by establishing a framework, giving it a defined character, or supplying the necessary background details. What's the next technique on our list? Step-back prompting. That sounds quite strategic.
Step-back prompting is indeed a very clever and often effective technique for improving the overall performance and accuracy of language models, particularly on more complex reasoning tasks.
How does it work?
It involves prompting the model to first consider and answer a more general, often abstract question that is conceptually related to the specific, more detailed question you ultimately want it to address.
So ask a broad question first.
Exactly. The answer to this initial, more general step-back question is then used as additional context when you present the model with your original specific task.
Why do that?
This initial step back allows the LLM to activate broader background knowledge, recall fundamental principles, and engage in higher-level reasoning processes before it attempts to tackle the specific problem.
Priming the pump, sort of.
Kind of, yeah. By considering these broader perspectives first, the model can often generate more accurate, insightful, and well-reasoned responses to the final, more specific prompt, and it can even sometimes help to mitigate potential biases that might arise from focusing too narrowly on the initial question.
Can you walk us through a clear example of how this step-back approach works in practice?
Certainly. Let's say we start with a traditional direct prompt asking the model to generate a storyline for a new level in a first-person shooter video game.
Okay, standard prompt.
The output you get might be reasonably creative, but it could also be somewhat generic or rely on common tropes.
Right.
Now, if we employ step-back prompting, we would first ask the model a more general related question. For instance, considering popular and critically acclaimed first-person shooter action games, what are 5 key fictional settings that typically contribute to a challenging and highly engaging level storyline?
Asking for common themes.
Right. The model might then come up with settings like an abandoned high-tech military research facility, a sprawling cyberpunk metropolis under siege, or a claustrophobic underwater mining colony.
Okay, it lists some settings. Then what?
Then, when we present our original prompt to write the specific level storyline, we explicitly include these 5 themes that the model itself generated as potential context. We then instruct it to select one of these themes and develop a detailed storyline based on that setting.
Using its own previous answer as input.
Exactly. The resulting storyline, perhaps now focused on the underwater research facility, tends to be much more specific, evocative, and engaging because it's drawing upon that broader, foundational knowledge that was activated by the step-back question.
That's a really clear illustration of how taking that initial broader step can lead to a much more focused and effective outcome for the specific task. Next on our list is chain of thought. This is a technique we hear a lot about in the context of improving reasoning.
Chain of thought, often abbreviated as COTI, prompting is a powerful technique specifically designed to enhance the reasoning capabilities of language models by explicitly prompting them to generate a sequence of intermediate reasoning steps.
So making it show its work.
Basically, yes. Instead of just providing a final answer, the model is encouraged to think step by step and articulate the logical progression it takes to arrive at its conclusion.
Why is that helpful?
This method has proven particularly effective for more complex tasks that require multi-step reasoning, problem solving, or logical deduction. You can often achieve even better results by combining chain of thought prompting with few-shot prompting.
Giving it examples of step-by-step thinking.
Right, where you provide examples of the step-by-step reasoning process. While more challenging, it's also possible to employ a zero-shot chain of thought approach by simply instructing the model to think through the problem step by step.
Just telling it, think step by step.
Yep, sometimes that's enough.
What are some of the main advantages and potential disadvantages of using chain of thought prompting?
There are several key advantages. One significant benefit is that it's relatively low effort to implement and can be used effectively with many readily available off-the-shelf language models without requiring any fine-tuning or specialized training.
Easy to try out?
Exactly. It also offers a degree of interpretability because you can actually see the reasoning steps the model took to arrive at its answer.
Which helps you understand how it got the answer.
Right, which can be invaluable for understanding how the model is processing information and for identifying any potential flaws in its logic. Interestingly, research suggests that using chain of thought can also improve the robustness of the model's performance when you transition between different versions or architectures of the same underlying language model.
Oh, that's useful. What about downsides?
Well, the main drawbacks are that the inclusion of these intermediate reasoning steps naturally leads to a greater number of output tokens being generated.
More text.
Yeah, which can result in higher computational costs and longer processing times.
Makes sense. Can you walk us through a specific example of how chain of thought works and the kind of difference it can make?
Let's take a classic example of a word problem that often trips up language models when approached directly. If you simply ask, when I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner?
Okay, I see the trap.
Right. A language model might incorrectly jump to the answer of 60, 3 times 20, or perhaps 63, adding the initial age difference.
Yeah, coming to stay.
However, if you employ zero-shot chain of thought by adding a simple instruction to your prompt like, let's think step by step, the model is then encouraged to break down the problem into a logical sequence of reasoning.
How would it reason?
It might then articulate. First, find the partner's age when you were 3. 3 years 3. 3 equals 9 years old. Second, calculate the age difference. 9 years, 3 years equals 6 years. Third, apply this age difference to your current age. 20 years plus 6 years equals 26 years old.
Ah, perfect. It follows the logic.
This step-by-step articulation of the reasoning leads the model to the correct answer of 26. You can also enhance this further by using single-shot or few-shot prompting, where you provide an example of a similar problem along with its detailed step-by-step solution within your prompt before presenting the target problem.
It's remarkable how just that initial instruction to think step by step can so dramatically improve the model's reasoning capabilities. What are some common use cases where chain of thought prompting proves particularly valuable?
Chain of thought is particularly beneficial for tasks that inherently involve breaking down a complex request or problem into multiple sequential steps.
Like coding.
Exactly. This makes it very useful for applications like code generation, where you can guide the model to first think through the overall logic and structure of the code before writing the specific lines. It's also a valuable technique for creating synthetic data.
Generating fake data.
Yeah, especially when you have a seed description and want the model to reason through the various assumptions and implications it should consider when generating related data points. Generally speaking, any task that you yourself would typically solve by talking it through or by outlining the necessary steps is a strong candidate for applying chain of thought prompting. If you can clearly articulate the sequence of steps needed to solve a problem, you can likely prompt the LLM to follow a similar line of reasoning.
Okay, we're really building up an impressive toolkit of prompting techniques here. What's next on our list? Self-consistency. That sounds like a method for ensuring more reliable answers.
Self-consistency is an interesting technique that builds directly upon the principles of chain of thought to further enhance the accuracy and coherence of the generated responses, particularly for tasks that might have multiple plausible lines of reasoning.
How does it build on COTI?
While standard chain of thought often relies on a relatively straightforward, greedy decoding strategy, self-consistency takes a more robust approach. It involves prompting the language model multiple times, each time with a slightly higher temperature setting,
Higher temperature. Why?
to encourage the generation of diverse and varied reasoning paths for the same question.
Get different ways of thinking about it.
Exactly. After generating these multiple reasoning paths, the technique then extracts the final answer from each of the responses and selects the answer that appears most frequently across all the different reasoning attempts.
So it takes a vote.
Essentially, yes. It performs a kind of majority voting over the different reasoning paths, aiming to identify the most consistently arrived at answer as the most likely to be correct.
Seems solid, but maybe slow.
It can provide a valuable pseudo-probability of correctness and improve reliability, but yes, it's important to note that this approach can also be more computationally costly due to the need to generate multiple responses for each query.
So it's like asking the model the same question multiple times, but encouraging it to think in slightly different ways each time and then going with the answer that comes up most often. When might self-consistency be particularly beneficial?
Imagine a task like email classification, where you need to automatically determine if an incoming email should be categorized as important or not important.
Okay, could be ambiguous sometimes.
Right. An email with nuanced language, perhaps containing a degree of sarcasm or a friendly but slightly ambiguous tone, might lead to different interpretations and thus different classifications, even when using chain of thought prompting.
So how would self-consistency help?
By applying self-consistency, you would send the same zero-shot chain of thought prompt multiple times with that higher temperature. If, for example, the model classifies the email as important in 7 out of 10 of its reasoning attempts, while classifying it as not important in the remaining 3.
Then you go with important.
Exactly. Then important would be considered the self-consistent and therefore more reliable answer. This approach helps to mitigate the risk of relying on a single, potentially flawed reasoning path and aims to converge on the most likely correct conclusion by considering a broader range of possibilities.
That makes perfect sense. By getting multiple reasoning votes, you're essentially increasing the confidence in the final answer. What about tree of thoughts? That sounds even more advanced than self-consistency.
Tree of thoughts, often referred to as TOTI, is indeed a further generalization of the chain of thought concept.
How so?
Instead of the model following a single linear sequence of reasoning steps, Tree of Thoughts allows the LLM to explore multiple different reasoning paths concurrently, effectively forming a tree-like structure of potential thought processes.
Multiple paths at once, like a branching tree.
Precisely. This makes it particularly well-suited for tackling exceptionally complex tasks that might require significant exploration of different options, the ability to backtrack from unproductive paths, and the synthesis of information from various lines of reasoning.
So it can explore dead ends and try again.
Kind of. The model maintains a tree where each thought is a coherent language sequence representing an intermediate step towards solving the overall problem. It can then explore different reasoning directions by branching out from various nodes in the tree, evaluating the potential of each branch, and pruning those that don't seem promising.
So, while chain of thought is like following a single, well-defined path, tree of thoughts is more like navigating a decision tree, where the model can explore multiple possibilities and backtrack if a path doesn't lead to a solution.
Exactly. It provides a much more flexible and deliberate problem-solving framework for highly intricate and multifaceted tasks where a single line of reasoning might not be sufficient.
Okay, we're venturing into some very sophisticated techniques now. Let's move on to REACT. What does that acronym stand for, and what's the core idea behind it?
REACT stands for Reason and Act.
Reason and act.
Okay. It's a fascinating paradigm that enables language models to solve complex, real-world tasks by tightly integrating natural language reasoning with the ability to interact with and utilize external tools.
External tools. Like what?
Think of tools like search engines, knowledge bases, code interpreters, or even APIs. REACT represents a significant step towards creating more autonomous and capable AI agents that can not only think, but also act in the world to gather information and solve problems.
Wow, agents that can do things.
Exactly. The fundamental idea behind REACT is that it closely mimics how humans often approach complex problems. We reason about the situation, we plan and take actions to gather more information or manipulate our environment, and then we observe the results of those actions to refine our reasoning and plan our next steps.
So it's not just about thinking and generating text. It's about actively engaging with the outside world to find information and take actions. How does this thought-action loop work in practice within REACT prompting?
The REACT framework operates through a cyclical thought-action-observation loop.
Thought-action-observation, got it.
First, the LLM reasons about the current problem or goal and generates a plan of action. This might involve identifying the need for more information or deciding to execute a specific tool.
Step 1, think.
Then, it takes an action, such as performing a search query using a search engine tool.
Step 2, act. Use a tool.
Following the action, it observes the results, for instance, the snippets of text returned by the search engine.
Step 3, observe. See what happened.
The LLM then uses these observations to update its internal reasoning, revise its plan if necessary, and decide on the next thought and potential action. This process repeats iteratively until the LLM believes it has gathered enough information or performed the necessary steps to arrive at a solution to the original problem.
It loops until it solves it. Can you give an example?
Sure. In our class materials, we looked at Python code examples using the LangChain framework integrated with Vertex AI and the Google Search Results package to illustrate REACT in action.
Okay, using LangChain.
The specific task we gave the REACT agent was to answer the question, how many children do the current members of the band Metallica have?
Huh. Okay. A real-world fact-finding mission.
Exactly. The agent then proceeded through multiple thought-action observation cycles. It first reasoned about needing to identify the current band members, so its first action was to perform a Google search for current members of Metallica.
Thought. Need members. Action. Search members.
Right. It then observed the search results. Based on these observations, it reasoned that it now needed to find information about the children of each of these members, leading to a series of subsequent search actions, such as James Hetfield children, Lars Ulrich children, and so on.
Thought. Need kids for member X action. Search kids for member X. Observe results. Repeat.
Precisely. After each search, it observed the results, extracted relevant information, and chained its thoughts to determine the next necessary action until it had gathered information on all 4 current band members and could provide the final answer.
That's truly impressive. It's as if the LLM is conducting its own mini research project to answer the question. What are some practical considerations to keep in mind when implementing REACT?
In practical applications, using React often involves continually resending the previous prompts and responses within the conversation context to maintain the state of the thought-action loop.
You have to feed it the history.
Yeah, keep it aware of what it just did. You might also need to implement mechanisms to prevent the model from generating excessive or irrelevant content between the thought, action, and observation steps.
Keep it focused.
Right. Setting up the model with clear instructions on how to use the available tools and providing good examples of the desired interaction patterns are also crucial for successful React prompting. It's a more involved process than some of the simpler prompting techniques we discussed earlier.
Definitely sounds more complex.
But it unlocks a significant increase in the complexity and types of tasks that language models can effectively handle.
This is definitely pushing the boundaries of what we typically think of as prompting. Now, let's move on to a technique that sounds like it could automate some of this complexity. Automatic prompt engineering.
Exactly. Having explored all these different prompting techniques, you might start to realize that crafting the optimal prompt for a specific task can sometimes be a complex and iterative process.
Yeah, lots of trial and error.
This leads us to the intriguing idea of automatic prompt engineering, often abbreviated as APE. The fundamental concept behind APE is to leverage the capabilities of a language model itself to automatically generate candidate prompts for a given task.
Using AI to write prompts for AI.
Pretty much. Instead of relying solely on human intuition and trial and error, we can prompt an AI to help us come up with potentially better prompts.
So how does this work in practice? Do we just ask one AI to write prompts for another AI?
It's a bit more structured than a simple request. Typically, you would start by providing a language model with a description of the task you want to accomplish. Then you would prompt this prompt generator model to generate a diverse set of potential prompts that could be used to achieve that task.
Okay, generate candidate prompts. Then what?
Once you have a collection of these automatically generated candidate prompts, the next crucial step is to evaluate how effective each of them is at achieving the desired outcome.
Test the generated prompts.
Right. This evaluation can be done in several ways. You might use automatic metrics commonly employed in natural language processing, such as BLEU or Rouge scores, which assess the similarity between the generated output and a set of reference outputs.
Automated scoring.
Or, and often more effectively, you can directly test the performance of each generated prompt on your target task and measure its accuracy or other relevant performance indicators.
Human evaluation or task-specific tests.
Exactly. Based on this evaluation, you would then select the candidate prompt, or perhaps a small set of the best performing prompts, that yields the best results according to your chosen criteria. The process can even be iterative.
I find the best ones.
Yeah, where you take the best performing prompt, prompt another model to generate variations or refinements of it, and then evaluate those new prompts as well.
Can you give us a simple, concrete example of how automatic prompt engineering might be applied?
Let's say you run an e-commerce website selling merchandise, and you want to improve the way your chatbot understands and processes customer requests for a specific product, like a one Metallica t-shirt, size small.
Using our Metallica theme again.
Yeah. You could use APE by prompting a powerful language model like Gemini Pro with the task. Generate 10 different natural language phrases that a customer might use to order a single Metallica t-shirt in size small.
Okay, asking for variations.
The model might then generate a variety of phrasings, such as, I'd like to purchase a Metallica t-shirt in size small. Can I order a small size Metallica tee? I want one Metallica t-shirt and the size is S, or get me a size small Metallica t-shirt.
Lots of ways to say the same thing.
Exactly. You would then take these 10 generated prompts and evaluate how well your current chatbot system understands each of them. You might find that some phrasings are parsed correctly while others are not.
See which ones work best with your system.
Right. Based on this evaluation, you could then select the best performing prompt or perhaps identify patterns in the successful prompts and use those insights to further refine your chatbot's natural language understanding capabilities.
That's a fascinating way to use AI to optimize how we interact with AI. Now let's shift our focus slightly to a very practical application of prompting. Code prompting.
As the name clearly indicates, code prompting is specifically focused on utilizing language models to assist with various aspects of software development and working with code.
Using LLMs for coding tasks.
Right. While Gemini's primary strength lies in understanding and generating text-based content, this absolutely includes prompts that are designed to generate new code, provide explanations of existing code, facilitate the translation of code between different programming languages, and even help with the often challenging tasks of debugging and reviewing code.
So we can actually prompt these models to write functional code for us in various programming languages.
Absolutely. Language models like Gemini can be incredibly valuable tools for developers, capable of generating code in a wide range of programming languages. This can significantly speed up the initial stages of development and help with repetitive coding tasks.
Like generating boilerplate code.
That, or even more complex scripts. For instance, you could provide a clear and detailed prompt asking the model to write a bash script that automates a specific system administration task, such as renaming all the files within a given folder by adding the prefix draft to each file name after prompting the user for the folder's name.
That's pretty specific.
And the model can often generate well-structured and even commented bash code that accomplishes this task effectively.
Commented code too. Nice.
Yep. Of course, as with any automatically generated code, it is absolutely essential to thoroughly review and rigorously test the generated code.
Always test the code.
Always. To ensure that it functions correctly, securely, and as you intended, as LLMs, while powerful, don't possess the same level of contextual understanding and critical reasoning as a human developer.
That's a crucial reminder about the importance of testing. What are some other ways we can leverage prompting when it comes to working with code?
Beyond just generating new code from scratch, prompting can be immensely helpful in understanding and working with existing code bases.
Like explaining legacy code.
Exactly. If you're part of a development team and need to quickly grasp the functionality of a piece of code written by someone else, you can simply provide the code snippet to the language model and ask it to explain what each section does, the overall logic, and the intended functionality. It can often break down complex code into more easily digestible explanations.
That could save a lot of time.
It really can. Another powerful application is code translation. If you have a script or a function written in one programming language, say Python, and you need an equivalent version in another language, like JavaScript.
You can just ask the LLM to translate it.
Pretty much. You can prompt the model to translate the code, and it can often provide a reasonably accurate and functional translation. Again, careful review and thorough testing of the translated code are paramount.
Test, test, test.
Always. Finally, prompting can be a valuable aid in the processes of debugging and code review.
Helping find bugs.
Yeah. If you have a piece of code that's producing errors, you can provide the code along with the error traceback or a description of the unexpected behavior and ask the model to help identify the potential root cause of the issue and suggest possible fixes or improvements.
Like feeding it the error message.
Exactly. It might even be able to provide corrected code and recommend further enhancements for better readability, efficiency, or robustness.
It's like having an always available AI pair programmer ready to assist with a whole spectrum of coding tasks. Now, before we move on to best practices, our outline includes a brief mention of multimodal prompting. Could you briefly explain what that entails?
Certainly. While all the code prompting techniques we've discussed still rely on text as the primary input format, the code itself is provided as text within the prompt. Multimodal prompting refers to a different and increasingly important area.
Different.
It involves using multiple different types of input data, not just text, but also things like images, audio recordings, or even video clips as part of the prompt to guide a language model.
So prompting with pictures or sounds.
Exactly. This allows for much richer and more contextually aware interactions. However, it's important to understand that multimodal prompting is a distinct and separate area from prompting for code within text-based models.
Requires different models.
Usually, yes. And its specific capabilities and how you construct these multimodal prompts depend heavily on the specific multimodal language model you are using, as not all language models have the ability to process and understand these diverse input formats.
Okay, that clarifies the distinction. Now that we have this impressive arsenal of prompt engineering techniques at our disposal, what are some overarching best practices we should always keep in mind when crafting our prompts?
Finding that truly effective prompt often involves a degree of experimentation, and, as we mentioned earlier, tools like the Language Studio within Vertex AI are incredibly helpful for trying out different approaches and seeing what works best.
Use the tools available.
Definitely. But beyond just experimentation, there are several key best practices that can significantly improve your prompting success.
Let's hear those crucial tips. What's number one?
First and foremost, and perhaps most importantly, provide examples whenever possible.
Back to few-shot prompting.
Exactly. As we thoroughly discussed with one-shot and few-shot prompting, this is an extremely effective way to guide the model. Well-chosen examples act as powerful teaching tools, clearly demonstrating the kind of output you're looking for in terms of accuracy, desired format, specific style, and overall tone. Think of it as giving the model a clear and concrete reference point.
Makes sense. Give it a target. What's next?
Second, always strive to design your prompts with simplicity in mind.
Keep it simple.
Yep. Your prompts should be as concise, clear, and easy to understand as possible, both for you as the prompt engineer and for the language model itself. Avoid using overly complex language, jargon, or unnecessary information that could potentially confuse the model.
If you don't understand it, the AI probably won't either.
Good rule of thumb. A good tip here is to try using strong action verbs that clearly and directly describe what you want the model to do, like summarize, translate, classify, generate.
Simplicity and clarity, those seem like fundamental principles. What comes next in terms of best practices?
Third, be as specific about the desired output as you can be. Avoid being too vague or generic in your instructions.
Don't just say, write about video games.
Exactly. Providing specific details in your prompt, often through the use of system prompts or contextual prompting, helps the model to focus its generation on exactly what's relevant and significantly improves the overall accuracy and usefulness of the results.
Got it. Be specific. Number 4.
Fourth, whenever feasible, use instructions that tell the model what to do rather than focusing on constraints that tell it what not to do.
Tell it what you want, not what you don't want.
Generally, yes. Positive instructions that directly communicate the desired outcome tend to be more effective at guiding the model and often encourage a bit more creativity within those positive boundaries.
But constraints are still useful sometimes.
Oh, definitely. While constraints, don't include X, avoid Y, still have their value, particularly for safety and enforcing strict formatting rules, prioritize clearly stating what you want the model to produce. As always, experiment with both approaches and carefully document your findings to see what works best for your specific use case.
Use instructions over constraints. That's an interesting and potentially powerful shift in mindset when crafting prompts. What else should we be mindful of?
Fifth, remember to control the maximum length of the output if it's important for your application.
Set that token limit.
You can usually do this either by setting a token limit in the model's configuration settings or by explicitly requesting a specific length or format in your prompt, such as asking for a summary in no more than 3 sentences or a description that's suitable for a tweet.
Good examples.
Sixth, for prompts that you intend to reuse or integrate into applications, consider using variables within your prompts to make them more flexible and dynamic.
Like placeholders.
Exactly. For example, in a travel guide prompt, instead of hard-coding a specific city, you could use a city variable that you can easily change each time you use the prompt.
Makes it reusable.
Yeah.
Smart. What's 7?
Seventh, don't be afraid to experiment with different input formats and writing styles for your prompts.
Try different phrasings.
Yeah. Different language models and even different configurations of the same model can sometimes respond in surprising ways to variations in how you phrase your requests. Try formulating your prompt as a direct question, a declarative statement, or a clear instruction, and pay attention to how different word choices and overall prompt structures affect the output.
So it's about finding the language that resonates best with the specific model and task. Are there any best practices that are particularly relevant to some of the more advanced techniques we've discussed?
Yes, a few. For few-shot prompting, especially when you're working on classification tasks, it's generally a good idea to mix up the order of the different classes in your examples.
Don't put all the positive examples first.
Right. While the overall order of your examples shouldn't theoretically matter, mixing the response classes, Virgi, positive, negative, neutral, can help the model learn the key distinguishing features of each class more effectively, rather than just memorizing the sequence of expected responses. A reasonable starting point is to aim for around 6 diverse examples.
Okay, mix up the classes. Anything else?
Also, it's crucial to stay informed about any updates or changes to the language models you're using and be prepared to adapt your prompts accordingly to leverage any new features or capabilities.
Models change, prompts might need to change too.
Exactly. Platforms like Vertex AI Studio often provide tools to help you track different versions of your prompts. And don't overlook the benefits of experimenting with different output formats, especially for non-creative tasks where structured formats like JSON or XML can make the generated information much easier to parse and use in downstream applications.
Back to JSON again.
As we saw in our pizza order example.
These are all incredibly practical and immediately useful tips. What about when we're collaborating with others on developing effective prompts?
Collaboration can be very valuable. It's always a good idea to experiment together with other prompt engineers or subject matter experts to get multiple perspectives on how to best phrase your requests and to uncover potentially more effective prompt designs that you might not have thought of individually.
Two heads are better than one.
Often, yes. And for chain of thought prompting, there are a couple of specific best practices to keep in mind.
Okay, specifics.
It's generally recommended to place the final answer after the detailed reasoning steps in the model's output, as the reasoning is what leads to and justifies the answer.
Show the work, then the answer.
Right. Also, when using Cote, and especially when combined with self-consistency, make sure your prompts and parsing logic are set up so that you can easily and reliably extract the final answer from the generated reasoning.
Make it easy to get the final result out.
Exactly. Finally, for standard chain of thought prompting, without self-consistency, it's often beneficial to set the temperature to a lower value, typically around 0, as you're usually looking for the most logical and deterministic answer based on the reasoning steps.
Low temp for logical reasoning.
Yeah.
That makes perfect sense, especially for tasks with a single verifiable answer. Now, one of the final best practices mentioned is the importance of thorough documentation. Why is meticulously documenting our prompt engineering efforts so critical?
Documenting your prompt attempts in detail is absolutely crucial for learning what works effectively and for being able to reproduce and iterate on your successes.
Keep a lab notebook, basically.
Exactly. Keep a record of every prompt you try, along with the specific language model you used, the configuration settings, like temperature and token limits, the full text of the prompt itself, the resulting output, whether the output was satisfactory for your needs, and any specific feedback or observations you have about the results.
All the details.
Maintaining this kind of detailed log, perhaps in a simple spreadsheet or a more structured document with key information like a prompt name and version, the intended goal, the model used, the full prompt text, example outputs, a clear status of whether it was successful, and any relevant notes or feedback will be invaluable when you need to revisit your work in the future, test the performance of your prompts on different models or updated versions, or troubleshoot any unexpected issues that arise.
Helps you learn and debug later.
Definitely. If you're working within a platform like Vertex AI Studio, make sure to save your prompts there and link to them in your external documentation for easy access and management.
Use the platform tools.
And if you're using more advanced techniques like retrieval augmented generation, RAG, also document key aspects of your retrieval system that influence the content being incorporated into your prompts.
Document the whole pipeline if needed.
Right.
That sounds like essential scientific practice for the art of prompt engineering. Do you have any final thoughts on how to best implement these best practices in a real-world setting?
Once you've refined a prompt to a point where it consistently delivers the desired results, it's a good idea to save it in a dedicated file within your code base or project for easier management, version control, and reuse.
Treat prompts like code assets.
Exactly. For any production systems that rely on carefully engineered prompts, it's also highly recommended to implement automated tests and evaluation procedures to ensure that your prompts continue to perform as expected over time, especially as the underlying language models are updated.
Test prompts automatically.
And always remember that prompt engineering is fundamentally an iterative process. You craft a prompt, you test it, you carefully analyze the results, you document your findings, you refine the prompt based on what you've learned, and you continue to experiment, especially as the capabilities of the language models themselves continue to evolve.
Craft, test, analyze, document, refine, repeat.
That's the cycle.
This has been an absolutely fascinating and incredibly thorough deep dive into the world of prompt engineering. We've covered a tremendous amount of ground today, from the foundational principles of configuring language model outputs
Temperature, top K, top P.
to an extensive range of powerful prompting techniques, including zero-shot, few-shot, system, role, contextual, step back, chain of thought, self-consistency, tree of talks, react, automatic prompt engineering, and even the specialized area of code prompting.
Quite a list.
And we've topped it all off with a comprehensive set of best practices that anyone can start applying right away.
Indeed. And the most important takeaway, I think, is that mastering the art and science of effective prompt engineering is becoming an increasingly valuable and essential skill for anyone who interacts with language models, regardless of their technical background.
It's not just for engineers anymore.
Not at all. By understanding and applying these techniques and best practices, you can truly unlock the remarkable potential of these powerful AI tools to meet your specific needs and achieve your desired outcomes.
So now that you're equipped with this comprehensive understanding of prompt engineering, we leave you with this final, thought-provoking question. What kind of novel insights, groundbreaking creations, or ingenious solutions will you now be able to prompt into existence?
Makes you think.
Consider the vast possibilities that this knowledge has opened up, and perhaps even share your own experiences and further questions as you embark on your own prompt engineering journeys. Thank you for joining us for this deep dive.